Hello everyone, welcome to XploreTalks. Today I'm here with another topic that is divisibility rules. Let's dig into the topic. Friends, do you know what divisibility is? And when can we say whether a number is divisible or not? Let's take a number 655 and find out the terms that will be included in a normal division. Let's divide it with 5. Now, 5 ones is 5. 15 is remaining. Again, 5 threes is 15 remaining now. So 5 ones is 5, 0 is left out. Here 0 is termed as the remainder, and whenever a number is divided by another number and we are left with 0 as the remainder, then we can tell that the number is divisible. Here 655 is exactly divisible by 5 because we got the remainder as 0. And 131 is called as quotient, 5 is divisor, 655 is dividend. From this we can also form a formula, that is dividend is equal to divisor into quotient plus remainder. Now let's learn divisibility rules. Divisibility rule 1. Every number is divisible by 1, and that's the divisibility rule of 1. Let's see an example. 566 when divided by 1, we get remainder as 0 and the quotient is 566. So here we got the remainder as 0. So we can tell that 566 is exactly divisible by 1. So every number can be divisible by 1. Now, divisibility rule 2. We can say a number is divisible by 2 when the last digit of the number is divisible by 2. Let's see with an example now. 564 when divided by 2, we need to check only the unit digit here, which is 4, and when 4 is divided, it is leaving remainder 0. Hence, we can say that 564 is exactly divisible by 2. Similarly, let's see divisibility rule 4. We can say a number is divisible by 4 when the last two digits of the number are divisible by 4. It is something similar like 2. In 2, it is last digit. In 4, it is last two digits. Again, the same thing with 8 also. We can say a number is divisible by 8 when the last three digits of the number are divisible by 8. And this divisibility rule is applicable for all the numbers which can be expressed in 2 power n form. That is, next 16, 32 and so on. Divisibility rule 3. A number is divisible by 3 when the sum of the digits of that number is divisible by 3. Let's understand it with an example now. Let's divide 2595 with 3. So, the sum of the digits of this number is equal to 21. And when 21 is divided by 3, it leaves 0 as the remainder. So, we can say that 2595 is also exactly divisible by 3. Now, the divisibility rule 9. A number is divisible by 9 when the sum of the digits of that number is exactly divisible by 9. And this is something similar like 3. And this divisibility rule is applicable for all the numbers which can be expressed in 3 power n form. Now, divisibility rule 5. A number is divisible by 5 only when the last digit or unit digit of the number is either 0 or 5. Divisibility rule 10. A number is divisible by 10 when the unit digit is 0. Let's see it with an example now. 155 is divisible by 5 because the unit digit is 5, and 155 is not divisible by 10 because we want 0 in the tens place. Next, 2510 is divisible by both 5 and 10 because the unit digit is 0, which is satisfying both the divisibility rules. Now the divisibility rule 6. From here on, we will be seeing how to deal with the composite numbers. Let's write down the factors when multiplied will give 6 as the product. We need to write the pairs, and the only possibility is 2 and 3. And that is the coprime pair itself. Coprime pair is a pair whose HCF is equal to 1. Now we can say a number is divisible by 6 when it is divisible by both 2 and 3. Let's see for another composite number, that is divisibility rule of 12. First, let's note down the pairs. So the first pair is 2 and 6. The second pair is 3 and 4. And that is the coprime pair because its HCF is 1. So now we can divisible by both 4 and 3. Divisibility rule 7. Divisibility rule 7 is a bit tricky, but it is really very easy. So whenever a number is given and asked to find out the divisibility rule 7, so we need to remove the last digit of the number and we need to double it. So whatever the product or whatever the value we are getting it, we need to subtract from the remaining number. If the number is 0 or if we can recognize it as a multiple of 7, so we can stop the process and yes, that number is divisible by 7. If not, again we need to remove the digit and again we need to continue the same process until we are able to tell whether the resultant is divisible by 7 or not. Next, divisibility rule 11. We need to find out the difference between the sum of the digits in odd places minus sum of the digits in the even places. And if the result is 0 or a multiple of 11, then the number is divisible by 11. For example, let's take 9647. So odd place sum is equal to 9 plus 4, which is equal to 13. Coming to the even place sum, we have 6 and 7 and their sum is 13. So now we need to find out their difference, which is equal to 0. So the number is exactly divisible by 11. Since we have finished all the divisibility rules, let's see some problems on the same. The first problem. So the given question is, if the number 1005x4 is completed by 8, then the smallest integer in the place of x will be. So now let's see the solution. So the given number is 1005x4. We know the divisible 8 it is if the last 3 digits of the number is divisible, then the entire number is also divisible. So from this, can I say that 5x4 is the last 3 digits and that should be exactly divisible by 8? Now, so the only smallest integer we can put in the place of x is 0. First case. So now 504 is exactly divisible by 8. So we can conclude that x value is 0. Let's see another. Now, how many 3-digit numbers are divisible by 5? Let's check out the solution now. We know the sequence of the 3-digit numbers that are divisible by 5 starts from 100 and then it will be going with 105, 110, 115, 120, so on up to 995. Now if we observe, the series is in the arithmetic progression where we get the first term or a as 100, the difference is 5 and the nth term or the last term is equal to 995. Using the formula, we can write it as 995 is equal to 100 plus n minus 1 into 5. 995 is equal to 100 plus 5n minus 5. Again, 995 is equal to 95 plus 5n. So by substituting and cross verifying, we get 5n is equal to 900 and n value is equal to 180. Therefore, we can conclude that the number of 3-digit numbers that are divisible by 5 are 180. Now, let's see one last problem. So the given question is, on dividing a number by 5, we get 3 as remainder. What will be the remainder when the square of this number is divided by 5? Let's check out the solution now. Let's consider the number which is dividend as well as some n and the quotient is some x. According to the dividend rule, we get n is equal to 5x plus 3. Now, n square is equal to 5x plus 3 whole square because we need to make the square of the number. Now we need to divide the square of the number by 5. So I can write it as n square by 5 is equal to 5x plus 3 whole square by 5. So here if we observe 5x and 5, they are exactly getting divisible by 5. So 5x and any 5x square, 30x and everything, it is exactly divisible by 5, leaving a remainder 0. So the only remainder we will be getting it is from 3 square, which is nothing but 5. So when I am dividing 9 with 5, we get remainder as 4. So the only remainder will be left out is because of this 4. Hope you guys learned a new topic today. Let's meet with another topic soon. Thank you. And please do like, share and subscribe to Explore Talks.